Let's represent this set of order pairs as a table, a graph, and a diagram. I'm going to start off with the table first, so I'm just going to do this. Actually, let me change this to black. It's like a T-chart, so I do this. My X values are going to go here, and my Y values are going to go here. My X values represents my domain, and then my range is represented by the Y values. All right, so range, domain. And my X values are simply just the first value for each ordered pair. And if you want, you could always label for organization X, Y. So think it's always alphabetical order, each pair. So I take my X values. So again, X values are going to go in this column here. But X values are 1, 1, and 1. So 1, 1, and 1. And notice for tables, we do write out if we have repeats because we're going to identify all the ordered pairs. We're going to represent each input and output in here. So we do write out repeats if we have repeats. And then my outputs are just going to be the second value, the Y values, which is the second number in each ordered pair. So my Y values would go on this side here, and there'll be 1, 2, and 3. And in this case, the inputs were all the same value, so it doesn't matter which order I put it in, but make sure they do match up. Like the way we have the order pairs here, 1, 1, 1, 2, and 1, 3 is the same thing. 1, 1, we got 1, 2, and then 1, 3. So it should still match up because in the table, it matters whatever you put with the inputs to match up with it. So it should be whatever you put for this input, the output should be right next to it in the table as well. And now that this is all set, I'm going to go to graphing it. So notice I put parentheses around it. So this is actually, since they look similar, we can use either format for graphing. So we need the order pairs. So this was already given in order pairs, but if you simply just add these brackets here, the parentheses, you could turn them into order pairs as well because they're pretty much the same thing. So now we're going to go to graph it. And all I got to do is draw an XY axis. And before I do that, when I do my sketch, I just look at what are my highest and lowest values for each one. So I know that my X values, I just got to go up to 1. My Y values, the range is from 1 to 3. So I know that I'm going to go at least up to 3. That's the highest Y value we have. So I'm just going to draw this like this. This is my X axis. This is my Y axis. And then I'm just going to put my numbers. So I'm going to put like this. And the points we had were 1, 1. So when X is 1, Y is 1, I'll put a point here. The next one is 1, 2. When X is 1, Y goes to 2. So when X is 1, I go up to 2 and put a point there. And then the last one, when X is 1, Y is 3. So when X is 1, I go here. And when Y is 3, we'll be right here. So these are my 3 different points. So notice that each order pair represents a point. So if they give you 3 order pairs, you know your final graph should have 3 points. And then the last thing we got to do is sketch a diagram of this situation. And for the diagram, you could just do rectangles or like an ellipse like this or ovals. And then in this side, we're going to put the domain, which is all the X values. And then in this side, I put the range, which is going to be all the Y values. For the domain, when you're doing a mapping diagram, make sure that you only put, like in this case, notice we have 3 1s. I would not put each one in here for my mapping diagram. We only write each element or each of the inputs once if there's a repeat. So don't write it more than once if there's repeats. So in this case, I put the 1 only once because these are all the same value. So notice in the table, we did list them all. But again, in a mapping diagram, you would not do that. And then now I'm going to put the Y values. So my Y values are 1, 2, and 3. 1, 2, and 3. So that makes up the range. And now what we do is we're going to draw arrows going from each input to the output. So 1 goes to 1. 1 goes to 2. And then 1 also goes to 3. Notice that in the mapping diagram, you could very easily tell if it's a function or not. Because if this input has more than one arrow coming out of it going to the outputs, it's not a function. And one way I always remember it is by thinking of this as like the people and places. One person cannot go to 3 different places at the same time. So that's what makes it not a function. Each input, in other words, can have exactly 1 output. It can only have 1 at most. And in this case, you can see it has 3 outputs. So that ruins the definition. So that's why it's not a function. You could also tell in the table the same thing. The same input had 3 different outputs. So I could tell if I have in a table format, I look for repeats in the inputs. And since I do have repeats, I check the outputs. If the outputs are different, then I know it's not a function. And then given the graph, if I have inputs or points that are stacked on top of each other, I know automatically is not a function. And notice that, again, these all represent the same exact set of ordered pairs. It's just different ways of telling if it's a function or not a function. So again, if you have points stacked on top of each other, it's not a function automatically.